Hello, everyone, and welcome to our webinar. This is Sydney speaking, and I will be hosting the webinar. The webinar today will be given by our CTO, Anthony Calderon. And the subject, as you all know, are the major enhancements that we've done in 2019 with iMachining. There's a lot of stuff that has to be brought over, that has to be given over, and you'll find this extremely interesting. Just a couple of housekeeping rules that we like to keep though before we get started. There will be time for questions towards the end. You can write down your questions in the questions area. If we do not have enough time to go through all the questions, do not worry about that. We have all the questions also written down and who actually wrote them down, and we will get back to you with the answers if we are not able to get back to you at this moment. Also, the webinar is being recorded and will be available on our website. If you go onto a website, you can see on my screen, we have the SolidCAM, www.solidcam.com. If you go into Professor, at the bottom, we have webinar recordings. Inside that area, tomorrow, this webinar will be available for everybody to review as well. So with that out of the way, I would like to make Anthony the presenter. And Anthony, you can go ahead, share your screen, and we are ready.
Okay. Hi, Sydney. Can you hear me?
Yes, I can.
Okay, great. So hello, everyone. Thanks for joining our webinar today. We're very excited in the iMachining team to show off the new features that we've done for SolidCAM 2019. So I will do a little bit of PowerPoint. I'm not a huge fan of PowerPoint, so I will not bore everybody with PowerPoint. The most exciting thing is to be in the software playing. But we're going, I'll go through a couple of slides here, and then we'll jump over to the software, and most of the presentation is going to be, in SolidCAM, showing off the new features. So this is the SolidCAM 2019 What's New PowerPoint and PDF. This is available on the website, so you'll be able to go through this yourself in more detail. In the iMachining section, I'm going to start actually from, the iMachining section starts here. I'm going to actually jump to the bottom right now because the feature recognition stuff from iMachining is the main portion. So we'll go over the smaller items we did first, and then jump to the big stuff. So one of the things we've done for iMachining 3D is we now support Stl Holders. So for all of our customers, I know in the presentation, mostly everybody is existing SolidCAM customers, and some are probably, new people looking at SolidCAM for the first time. So, you've always been able to select well, not always, but recently you've been able to select Stl Holders, and now you can use Stl Holders for collision protection in iMachining 3D. So whatever the shape of the holder is, it is now protected. The holder is protected by the envelope or the spun profile of the holder, because obviously it's spinning in the CNC. So whatever the shape of the holder is, it is spun, and we use that for the gouge protection and collision protection. And then the second thing we've added for iMachining 3D is limiting our depth of cut to 1 ACP. So for everybody who is already using iMachining and cuts with iMachining, the ACP, or the axial contact point, everyone knows is a very critical function of the cutting out at the CNC. This has to do with vibration and letting you know how well the cut, is going to sound or not sound at the machine based on, the diameter of the tool, number of flutes, and the helix angle, and the depth of cut. So what I can show here, and I just have a nice simple part, not that this would be a part we would cut, but just a tapered rectangle, just to show that, with iMachining 3D, we start from the bottom, and then we, step up along the part. So I have the simulation open here. So I'll just rewind back. This is our new SolidCAM simulator. So what we see here is, as we cut from the bottom up, we go from the deepest amount of flute engagement to the shallowest amount of flute engagement. And this is the best for cutting, is to get the most amount of material engaged with the tool as possible. So as we step up this tapered rectangle, the depth of cut is getting less and less and less and less and less as we go along. And at some point we come all the way up here to, let's say, the top, and you can see we have very little engagement with the tool axially. And this is where we get vibrations. So as for anybody that is, as I said, already using iMachining, we call these axial contact points. So these are the number of teeth that are engaged axially along the flute, along the tool. So what we have is, when you're in the iMachining operation and when you're in the technology wizard, we tell you for every depth of cut what you're doing, what's the ACP. So the ACP is 3.18. So this means for the 25 millimeter depth of cut with this tool, we have 3.1 teeth engaged with the cutter at all time. So the goal here is to have at least 2 teeth engaged. This is what gives stability to the end mill, because we don't want the end mill popping in and out of the cut and relaxing and taking the load on and off. And this is our goal. Now in iMachining 3D, what we end up with is we do the step up, right? So we have the largest depth of cut, we have a good ACP. It's stepping up, it's stepping up, it's stepping up, and then all of a sudden it drops below those 2 teeth being engaged. And then at that point it introduces vibration. Now it depends on your machine, your material, and the tool how important that vibration is. If it's aluminum and it's a big tool, not a big deal, right? So a little bit of vibration is not going to chip the cutter. It's not going to be a big deal. The smaller the tool, the more important it can be. So even in aluminum, I mean, if you're trying to cut with a 30,000 end mill, a 16,000 end mill, something really tiny, and I mean, we have customers that cut with iMachining all the way down to, we've had customers cutting with 4 6,000 diameter end mills in steel. Those tools, even in aluminum, really care about the vibration. So what we have is this checkbox now called limit depth to 1 ACP. When you turn this on, any depth of cut that is less than 1 ACP, and we show you here in this grayed out field that it's 7.85 millimeters. This is exact number, so it's never a round number like 2 or 4 or 6. It's always some unique special number. When you turn that on and then you calculate the tool path, you can see over here out in the screen in the graphics view, you can see that the tool path got trimmed. If we relaunch the simulation and just play this over again, I'll zoom in a little bit. You can see that as we get towards the top, eventually the tool path will stop. So here, we will stop the tool path when it gets less than 1 ACP, and then that will be left over for another following operation to take care of. So in this instance, it could be, you could come in with a smaller tool to use rest machining. You could come in with maybe another tool that, let's say, is more general purpose. A lot of customers nowadays are starting to use, special tools for iMachining, because the way iMachining can manage the cutting force and the load, you can get a better tool, a more expensive tool that has special grinds that perform better with how iMachining is meant to be, a deep depth of cut, very controlled engagement, and very controlled chip thickness. But those tools, let's say, are a little bit more sensitive when it comes to chatter, because the flutes and everything are meant to be a little bit more sharp. There's special things that they do with them. Where if you get a general purpose end mill, or even something with, let's say, a bull mill, even just taking an end mill and putting a small corner radius on it helps with the abuse that the tip of the cutter takes up. So you can choose how you like to, what tool, remove this remaining material. But at least at this point now, if you have a special end mill and you are having some chattering problems, or some teeth being chipped or something like that, you can now turn on this limit depth to 1 ACP in iMachining 3D, and it will help save the chatter on that tool, and you'll get longer tool life. And now let's go to the most exciting stuff. iMachining feature recognition. From the beginning of iMachining has always been about cutting at the CNC. And I think this is what really has made, well, I know this is what made iMachining the most unique tool path out there, is that our focus from the beginning was how do we cut on the machine CNC and get the best possible result on the CNC. And now what we are talking about here is not the result on the CNC, but the result inside the CAM software. So what I'm going to do real quick, just to give for people that are maybe a little bit more new to iMachining, here's our kind of general presentation we give on SolidCAM and iMachining. So we have iMachining 2D and 3D, and in the end, everybody always sees time savings, 70% or more in the cutting. iMachining 2D, it was a revolution in CNC machining. So in iMachining 2D, it's all about cycle time. Lowering the cycle time at the machine, whether you're cutting aluminum, steel, titanium, it doesn't matter. We've always been focused on the cutting. And because of the cutting, we've generated a smart tool path. This is the smoothest tool path. It calculates all the loads for the tool at every single point along the tool path. The tool path looks nothing like any other tool path out there because it's all about removing the material, not about actually trying to put some specific pattern down on the model. And then from the beginning of cutting, we realized we needed a technology wizard to assist all of our customers and anybody cutting with these style tool paths to say, okay, how, if I go with a 13mm tool or a 1/2" end mill tool, how do I get the right feeds and speeds for that tool on cutting titanium or cutting aluminum or cutting stainless steel, whatever the material may be. So we generated, from the very beginning of iMachining, it came out with the software over 10 years ago, the tool path plus the technology wizard. And both of these things were meant to get the best cutting at the CNC. I think everybody's familiar with the normal standard style tool paths that have been around. We have just kind of pocket strategies that are generally offsets or zigzags. This leads to non-smooth tool paths, overloaded tools, and we also get air cutting in standard tool paths. With iMachining, everything is smooth and tangent. All the step overs are controlled, so we manage the cutting load at every point of the tool path, and we get exact stock machining. iMachining is the 2D tool path is working from a minimum and maximum cutting angle, and for each cutting angle that we cut, we automatically adjust the feed rate to get a constant cutting load on the tool. So as you see here in the standard presentation, everything is about cutting at the CNC. How do we get that 70% or more cycle time? So it's all about cutting at the CNC. And most of our presentations that we talk about with iMachining has always been the tool path, the machine. And if I just jump down to the bottom here, we have the technology wizard. How do you get the right feeds and speeds? We use our technology wizard. Our axial contact points, which we just talked about a second ago. So this is a huge thing that we talk about. Okay, axial contact points, this leads to vibration. Vibration is bad. That's what lowers your cutting feed and speed. In the end, cycle time savings. So even in aluminum here, you can see you can get a 65% cycle time savings in aluminum with a large tool. So a lot of people, think, hey, we cut fast in aluminum. We run big tools, shallow depth of cuts. We get great cycle times in aluminum. Even with aluminum, we have tremendous cycle time savings. Titanium, 80% savings. And this goes on and on. So as you can see, the point I'm trying to make here is everything has been about cutting at the CNC. And now we come to what we've done in SolidCAM 2019. And this is our iMachining feature recognition. And as I said, this is about, in the past, how could we give you time savings on the CNC? Now it's become, how do we give those same time savings while you're programming your part in SolidCAM? How do we take something where a part takes you an hour to program? How do we knock that programming down to 15 minutes for you? And this is where we come in with our iMachining feature recognition. Now, when you go into the iMachining operation, there are geometry definition modes. So we have 4 modes on how you are defining your geometry. The first one is feature recognition by faces. then feature recognition by chains. We have outside feature recognition, and then we have chains without feature recognition. And this one's important because the chains without feature recognition is basically the way the toolpath worked in the past. There's no feature recognition. It just works off of chains, and I'll go over that and show what that means. So feature recognition by faces. What this is basically you are picking faces on your model, and that's it. You say, hey, I want to machine this face, I want to machine this face, I want to machine this face, and then we are doing everything in the background to do machinable feature recognition, which I'll talk about why I call it machinable feature recognition. Then we have feature recognition by chains. So chains are important because you might not have a face that you are actually trying to cut down to. So if you have like a through pocket, something like this, or maybe you have a side profile, that you're trying to cut the side of, you don't actually have like a floor or a face that the bottom of the tool is cutting to that defines, hey, this is the face I want to cut. You're cutting something with the side of the end mill. And then we have outside feature recognition. This is, pretty standard thing that a lot of times when we program parts, what do? We cut from the outside shape of whatever our block of aluminum is or block of steel, whatever it is, and take the outside shape of our part. So this was a simplified button. You just say, hey, I want to cut the outside of my part, and it automatically works from whatever the updated stock is and machines to the shape of the part. And the last thing, as I said, was our chains without feature recognition. So this is the, let's call, legacy way in SolidCAM. Legacy kind of makes it sound like it's bad, and it's not. This is just chain definition. So here, that's not using any solid model geometry. It's not using the updated stock. It's not using the target. It's not trying to protect against fixtures. This is just, hey, I want to model I want to pick either my sketch or my chain off my model, or I want to make a sketch in SolidWorks or InventorCAM, whichever software you're using. You mark what's open and edge, what are open and closed edges. This also affords you the ability to cut things into your model that might not actually be in your model. So, sometimes you may have to rework parts. And if you're reworking a part, sometimes they just come in with a drawing and say, hey, this pocket, you need to modify it a bit and just, cut this ledge in, a few thou or, a couple microns or something. So sometimes, in machining, we don't necessarily have the solid model that shows exactly the thing that we need to cut. Or maybe there's a piece of fixture in maybe there's a fixture you need to clear out or something like that. So with the legacy mode, you still have the tools to just define a chain, sketch a chain, cut a chain, and do everything as normal. So none of that, is taken away. Let's see, I don't need to go over, I won't go over that slide, not so important. There's lots of previews that we do, and I'm gonna go over some of this. When we do extensions, there's two styles of extensions where either the pockets are extended tangentially to the end of the geometry, which you can see, is extending up here, or we find the closest point to the stock and we extend to there and we put a little nice billet in there so the tool is overlapping and blending nicely in. So even though the software is doing a lot of feature recognition for you in taking these decisions, you still have control because, when it comes to certain pockets, you might have to decide how you would like the tool path to cut. And we have cam settings for all of these things, so these are important. That you can you can turn certain things on and off. You can also set the default modes. So existing SolidCAM customers, if you guys are familiar with using the chains and that's what you like to default to, and then you want to use the the faces and the new feature recognition, you can change this stuff as the defaults in the software. So now the most exciting thing is let's get into SolidCAM and let's check out the new feature recognition. As you can tell, this is the model from the PowerPoint presentation. So, I try to use the same part. That way, you kind of see some of the, see the same thing between the PowerPoint as you're going through, and it connects well. Also on the PowerPoint, there is and I think everybody who is used to our PowerPoint presentations know that there is, on most of the slides, there is a YouTube button, and you can watch a somewhere anywhere between like a minute to a 4-minute or 5-minute presentation on this specific slide. So all the things that I'm going to go over today, I'm basically touching on a lot of the slides here, but I might not go into exact the same amount of detail that, you know, these YouTube videos go into for each slide. So I would definitely recommend, especially for people that are using the software already, and you want to understand some more details, click on the YouTube buttons. They're really short, they're really concise, and they kind of go a little bit deeper, I think, than what I'm going to talk about here today. So we have this part in SolidCAM, and as you know, all of us are programmers, and we're thinking, okay, how do we go about starting to machine this part? You know, because this is our question as a programmer. It's okay, I have this part, it's in a block of some material, I have fixtured it somehow. Now, how am I going to decide how I want to cut this part? You know, so usually we are deciding, okay, I want to cut this face first and then this face, and we're trying to figure out the order of our machining operations. And in that context, we're also trying to decide what tools we're cutting. And then as we program along, you know, we go to the simulation, we see what the toolpath looks like, we see, you know, we see how everything is going, we make changes. So the entire time, you know, machining is very, you know, I would call it very artsy. You know, each programmer finds their own way. I could give this part to 30 different programmers and everyone would pick a different way. Different size tools, some would cut this face first, some like to cut the outside first. Everybody comes up with their own way. So in machining, there is no standard that I've ever seen where everybody's like, yeah, this is the exact same way we cut parts. This is how it works. It's an art form. You know, it's you take your tools and you decide how you want to machine your part. So I'm going to go through how I might machine this part, but what you'll see as we go along, the software lets you just, now it's easy. Not that in the previous versions you could always program how you like, but now it's become easier because we do so much more things for you. So I'm going to turn on my updated stock so I can see, you know, what my stock looks like. And now I'm just going to start picking to program some stuff. So first thing I want to do, I want to try programming this face over here. So I am going to add a new 2D Imachining operation. Move this over to the side a little bit. Now you'll see that when you're in feature recognition by chains, we can pick our geometry directly from the operation dialog. So we have this little box here. It says click here to begin selecting faces. You pick a face, you click off. When you pick the face, we know the boundaries of the face and we say, okay, we understand what face you want to cut and we understand the extremities of it. Now we want to go select our tool. I have in here a 20mm end mill. Let's just grab this guy. Soon as I selected the tool, you can see that we get a new preview now out in the graphics area. So what is this preview? This is the machinable feature from the face we selected. So if we go to let's say a top-down view, and I hope all this comes through good. Sometimes with GoToMeeting, it does degrade the video quality a little bit. So sometimes some of this like shading and things that you get in SolidWorks don't always come through. But what you'll see here is, you know, we pick the face and then you get this blue shaded region. This blue shaded region you can see is extended to the stock. If we zoom in down here, you can see that we have this undercut, and you can see that the machinable feature automatically removed and protected against that undercut. And if we look, we can also see that the machinable feature recognition found the highest point in the stock, which was 1 millimeter above the coordinate system, and that the lowest level of the face was minus 45 millimeters. Now, in this, all I want to do is say, hey, I want to finish the floor at the same time. So as you pick your tools, you can say, is this tool finishing the wall or is it finishing the floor? We can save and calculate our tool path. And that's all we had to do. So to machine this feature, or this face, all I had to do was select the face I wanted to machine and the tool I wanted to machine. And it found the levels, it trimmed it up to the stock. I didn't have to worry about making sketches in SolidWorks and everything. Now let's just say I want to go, I'm just going to jump to the new simulation real quick just to show what this toolpath is doing. So as you remember, I picked the face of the model, right? So that face, as we can see, is something like, I don't know, this is a 20 millimeter tool. So it looks like there's about like 8 millimeters of stock on this front face. You know, normally if we would have just picked a chain or something, the tool would just plunge down on the stock and it wouldn't know. Now in here, it knows about that. So what I'm going to do is I'm just going to play the simulation in fast mode. In the new simulation, we have a recording option. So you can see this red bar means that we are now recording the toolpath. This, when it's recorded, this allows us to play the simulation forward and backwards and scroll through it. So this is really, 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 really useful. And I'm going to, let's say, make this nice and big. So I can bring the tool all the way to the beginning, and then I can slide. Now I can just use my slider and slide through the toolpath. So you can see the toolpath, you know, as I'm machining, always plunging out in air. So we plunge out in air, we machine the first level, scroll through, and then, you know, once again, you can play forward and backwards, which this is new for SolidCAM 2019 and our new SolidCAM simulator, which is in beta, but it is available for all customers who are using 2019. You have this DVR capability where you can just slide through the solid verification and see, you know, exactly what's going on, which is very, very, very useful. I can use my stock and target comparison to see what has been machined and what's finished. So we can see here that the bottom face is finished, and we can see that the walls, and also if we zoom in underneath here, so here's that undercut that I talked about. So even though we machined the face and we told the software, hey, I want to machine the face, the machinable feature recognition automatically detected that there was going to be an undercut. It would gouge the, you know, it would cause a gouge and cut away some of the model. And it removed that section from the pocket and protected against it. Now, as we come back into the operation, when you're using the software now, there is a lot of graphical feedback that we are providing to you as you're programming, and you want to get used to, I would say, turning on and off several of the different things that we do, so that way you can understand the toolpath and what you achieved. So in the end, as I say, you know, it's an art form as you're programming. You pick a face, you program it. You know, as a machinist, we look at the toolpath. Okay, how's the tool plunging? You know, we always look at rapids, right? Where are the rapid moves? What do they look like? And then we want to know, okay, where was there leftover material? How, you know, how many depth of cuts did it do? So there are all these different tools to analyze what's going on, and you need to get used to using them. So let's say, you know, after you calculate the toolpath, one of the first things you might want to do, you might want to turn off the toolpath display. So the toolpath display, you know, this allows us, as I said, to see rapid moves, see where the first plunge point is, see how many depth of cuts. If you don't have the toolpath displayed on, you will see the machinable feature. So this is this blue region with the levels and the chains. There is a button here for disable preview. If you click that, it temporarily disables that graphics preview. Now, if you have turned on the updated stock visualization, which I think is super critical, because as we're programming, visualizing where the stock is at each operation in the tree is really what dictates how, you know, how we program and what tools we're using and everything. So, you know, using the updated stock is important. So you can turn the updated stock on and off through the checkbox once again. And the other thing that is very useful is you can right click on the updated stock icon and say, does it include the current operation or not? So if we have the stock at this operation, the default is to include the current toolpath. So this, you can see the pocket is machined away. If we want to disable that, now it'll show the stock at the beginning of the operation. If you want to see the stock at the beginning of operation, now it might be nice to see the machinable feature preview that we do in iMachining. So here you can see the initial stock, you can see how it trimmed itself up to the stock, you can see these things. So in the end, it's all about interrogating what the toolpath is doing and if the result is what you like. So you have, so once again, you can turn off the graphics preview here for the machinable feature. You can turn the toolpath display on and off. You can turn the updated stock visualization on and off. And you can also say if the updated stock visualization includes the current toolpath or it doesn't include the current toolpath. And then obviously you can go to your, you can go to the simulation. And for everybody that's familiar with SolidCAM, we have our host CAD simulation. So you can see your, your wireframe over top of your SolidWorks model or your Inventor CAM model. We have solid verification. This is removing the material from the part. And as we showed before, we also have the new SolidCAM simulator, which the new SolidCAM simulator is a combination of all of our other simulators brought into one environment. So in the new SolidCAM simulator, you get the ability to do solid verification, which is, what we showed earlier. I can turn off the stock and target preview. So here you can get solid material removal. You can also show the toolpath. You can also dynamically pick and set the toolpath at any point. You can double click. There's a whole section in the PowerPoint slide on the new simulator. So even though it's in beta, it is extremely useful for anybody using SolidCAM. So, I mean, we already, for customers that are already using SolidCAM 2019, they're already using the new SolidCAM simulator, even though it doesn't have all of the features yet of all our other simulations. The things that it does, the fact that it has a DVR recording, the fact that you can play forward and backwards, I mean, all these things that you get in one environment, everybody's, I think everybody's using it and using a combination of this simulator and the old simulator, depending upon, what features they need. And in the new simulator, you can turn solid verification on and off. So if you just want to be looking at wireframe toolpath, you can do that. This is obviously very nice if you're working on 3D models and stuff like that. I mean, we're dealing with the 2D stuff, so solid verification is what we're looking for. But for 3D customers, being able to just be able to do wireframe toolpath is important. So now we programmed this this first phase, and I went over a lot of stuff, but now I'm going to start going a little bit faster because we're going to see how the new feature recognition lets you program quick. So we have in our operation this first toolpath, and now what we want to do is I decide what do I want to cut next. I'm going to say I want to cut this through pocket. So we will make a new 2D Imachining operation. This time I'm going to do feature recognition mode by chains. I am going to go select the chain. I have now picked my bottom pocket. I am going to go select two tools. So we want to now select the first tool we used the first time, which is our 20 millimeter. Once again, you can see as soon as I pick the tool, we got our machinable feature preview with the upper levels and lower levels. I am going to select another tool. So the second tool is the 10 millimeter tool. And this one, I tell it I want to finish the wall. Save and calculate. As you can see, that was maybe 5 or 8 clicks. So, add a 2D Imachining operation, chain, tool, second tool, finish wall, and now you get in one operation, you now get all of the machining automatically done for you based on the stock, the target, the fixture. You get 2 operations out in our CAM tree because later on you might want to reorder your tool path. So even though both tools are done in the same operation, you can they are separate items in the CAM tree, so you can reorder them. Now we can go to our simulation. Let me just zoom in here a little bit. Once again, I'm going to use the record option because it does allow us to see things a little nicer. So you can see the first roughing tool, and now we can drag back through. So you can see, we get the two different colored operations down here. The first is the roughing, we rough out. We can see that the roughing leaves a good amount of material in the corners, which is why I picked a smaller tool for finishing. And then we have our iMachining finishing of the walls, which goes in and cleans out all the material. And it does that first, so that way the finish pass, when it goes along, does the finish pass in, I'll just single step through this. So the finish pass is done in one depth of cut, just like the iMachining roughing. And since we already cleaned out all the areas where the tool would over engage, even for finishing, you're not going to get the normal like squeal in the corner, even when you're doing finishing. So this is our iMachining finish for walls, where we calculate all the areas that the tool would over engage. We clean those out previously. We leave a tiny amount of material on the wall, so there's no blending issue. So when the final finish pass does come along, it does just clean up that wall a little bit, so that way you get that nice looking blend out on the part. There we go. If you like to use the stock and target comparison, which it's so awesome in the new simulation, it's so useful. You have these slider bars that you can see how much material is left over everywhere. So you can go through these sliders and say, okay, where's all this difference of, between 0.25 and half a millimeter, 2.5 millimeter, 5.5 millimeter. Generally for me, as I'm programming, and anything more than, 0.25 millimeter, which is, I don't know, I think that's 15 thou. So anything over 15 thousandths is rest material for me, so paint it all in one color. But sometimes when we're doing 3D and stuff like that, we want to be able to see maybe a little bit more color ranges. So you just drag the slider, and now you can see the different color ranges. So everything in this new simulator is meant to just be very user-friendly, very simple, very easy to use. So we machine this through pocket. Now imagine if we said, you know what? I didn't want to cut that front face first. What would happen with our two operations that just machine that pocket? Well, let's just say we dragged the first cutting after those two. If I just edit the operation for the through pocket, all I did was edit, and I opened up the operation. You can see that we've automatically detected that the upper level has already changed because there's material up there. So the updated stock changed because we didn't machine that level, that pocket first. So now the upper level has changed for this. I didn't have to figure this out. The software is doing this for me. So I think everybody that's familiar with previous versions of SolidCAM, as you reorder everything, it is in your mind as a programmer trying to keep track of, okay, if I reorder something, what is the highest point of the stock? What is my lower level? Are all my lead in and lead out still good? Are they gonna, am I gonna be able to plunge out in air? Now we are taking care of all of those little tiny decisions for you. And it's not to say that you can't go in and change those decisions, but we're doing these for you now. So SolidCAM is now saying, hey, you're the programmer. You pick what you want to machine and what order you want to machine it with what tools you want to machine. We're not going to tell you any of that. That's not the SolidCAM's, that's not our way of programming. Our feature recognition says, hey, you pick your tool, you pick what face you want to machine in what order, then we will do all the machinable feature recognition and do all those little decisions that you have to do manually. We'll do them for you. We'll find the upper level, we'll find the lower level, we'll extend it out to the stock. If you pick something that would cut or gouge another piece of your target or your fixture, we'll protect it for you. We're making those decisions not something that you have to. So your programming now just becomes more or less, I don't know if, kind of like point and shoot or plug and play. You're just kind of saying, hey, I want to machine this face, I want to machine this face, I want to do it from this side, and SolidCAM is just letting you, oh, sorry, needed to take these two and move these down. So I'm going to go back and move them to the order they were originally. Now we're going to program some more. So 2D Imachining. We're going to do feature recognition by chains again, because what I want to do is I want to cut this side over here. I need to switch to my Mac 1 position 2. So this is my orientation to cut from the side. In this part, we're in a 5-axis machine. Define my chain. I'm going to use up to entity. So I'm going to start on this edge. So I want to machine from this edge up to this edge. I will turn on my updated stock because I like to see all this. So we can see already, I picked this chain. You can see the stock is over here. You can see that the stock, when we look at it from, how the tool is going to be cutting, we can see the stock is kind of uniquely shaped. I'm going to go grab a tool. One of my tools is an extended length in here. Is this the long? Yeah, I think this is my long flute. Nope, I'm sorry, I have a long, just an extended reach tool. We'll select that one. Now, when we do the feature recognition by chains, we automatically take where the chain is to be the bottom of the pocket, or the bottom of where you want to cutting. Obviously, I picked up here, so I want to cut deeper. So we come over to pocket depth. I want to machine down to like this bottom of this fillet. In reality, I probably want the tool to go a little bit further, so I'm going to click here. You can see as soon as I click that, you can see the region is extended to the stock. You can see our upper level is 18 millimeters. It automatically found that. And the bottom is the point that I picked. So I will just calculate this toolpath. I'm going to go to the new simulator, and I just want to simulate what this thing's doing. I will turn off the updated or the compare stock and target. Let's play this. Let's zoom in a little bit. So as you can start to see, we are ending up with here kind of this thin little section down here in this area. As a programmer, I might look at this because now that I see it in the simulation, I might go, that might sound a little funny in the machine because it's kind of a thin wall. It might start chattering a little bit, and I might want to change my machining order up a little bit. So if we go back to the beginning of what the cut looks like, I would look at this and go, if I could put a tool path from the top side and just rough out a little bit of this face, that would get rid of that little chunk that's over there. So this is pretty easy to do. I will switch back to our Mac 1 position 1. So what I want to do is I want to machine these two faces, and I want to do it from the top view. So I'm just going to highlight those two faces. I can now right click and say add a 2D Imachining operation. I want to do it in between these two operations. The pre-select automatically grab the faces, so you can pick them beforehand. It saves, might save you a little bit of time instead of having to do it in the operation. And I calculate this toolpath. Now it's going to machine away those two faces. Now when I come back to my side cuts, as soon as I open up the operation, you see the preview updates. So you can see there's a little bit of material now on that wall because we didn't finish the floor. And then we get this. So if we calculate this, and now let's go to the simulation. Let's see what the toolpath looks. Oh, apologize. Wanted to go to the new simulator. Now we see the toolpath is trimmed up to just cutting those corners. So I didn't go back and I did not have to make any changes to do that toolpath. By me just inserting an operation before that roughed out those two faces, I got the toolpath automatically updated in this other operation. One thing you kind of notice as I'm using the software, I'm not really using save and copy a lot. I think generally a lot of people use save and copy, but what you see in the new feature recognition stuff, it's so easy to start from a blank operation because you pick your tool, you pick your geometry, you get your tool path. But in an instance like this, I have this feature on the same side, just on the opposite, on the opposite side of the model. So this is a good example. If I want to use save and copy, I can copy this operation. The only things I really need to change here is I want to switch my coordinate system to come from the opposite side. And now I want to pick my geometry to be from the other side. So up to entity again. We're going to pick this. We will accept our chain. We want to help the feature recognition decide what side we want to cut. We want to be on the left-hand side of our chain. It's not a requirement, but it does help the feature recognition because we are trying to determine automatically from your selections what you're actually trying to cut. So I will zoom in also and pick the lower level. We do that. We save and calculate, and now we get our tool path, which is machining, machining the same cut, but just from the opposite side. We can go into the simulation if we like. And see the result of that. Now, what I would like to do is I want to deal with these two little undercuts underneath the here. But first, I realized, you know what? I actually want to deal with cutting the outside shape, because as I was going through, I forgot, I wanted to cut the outside. Because I don't want to take the little tool that's going to cut through here. I don't want to deal with all this material that's up here. So we are going to go to our, let's see, we got our outside cutting there. Then after the outside cutting, we did the through pocket. So let's say after the through pocket, we want to do the outside cutting. So we will come to here, this point in the cam tree, add a new operation. We want to pick the outside feature recognition. Here you can see there's no geometry to select. It's automatically determined. You just need our coordinate system. We will go select our tool. This is our 20 millimeter, and here I have a long flute version because I need something long enough to cut through the part. You can see the machinable feature preview automatically showed you cutting from the outside to the target. You can see as soon as we calculated that, all of our operations became uncalculated because it affects all of them. We have a button here that says calculate all related operations. So if I would have pressed that, it would have calculated this, and then it would have went and calculated all the other operations following it. But I think it's a little bit more interesting to go see real quick what was the what was the behavior difference of any of these operations. So if we open up the through pocket, there is not much going on here. This operation pretty much stayed the same. Oh, and I see this outside. I actually meant to throw that after this one. Okay, so we have the roughing, we have the finishing, then we have our outside cutting. Let's calculate that operation. We have our cuts that are coming from the top. You can see now these, since we cut the outside, they're now trimmed up. And if I zoom in, which is going to be a little hard, I never finished the outside of the stock, and I did that on purpose. So I wanted to show that even though there's just a tiny bit of material, this material is automatically picked up from the feature recognition. And some people might say, oh, well, that's not that much material, but that little bit of material can be the difference between the tool plunging on material or not plunging on material. And so this is, these little tolerances of just a few thousandths here and there, these are things that are hard for, let's say, us as programmers to catch. But the feature recognition catches it automatically for us, which is really, really cool. Oh, and as I was talking, I forgot to calculate the operation. So let me just calculate this. And we have our two operations, which are, now you can also see the same thing with, the side cutting. The side cutting, the upper level was all the way out here, but now it's not there anymore. It's now at 0.2 millimeters because that's how much stock was left on the outside. And as I said, we really, maybe sometimes the information we provide is a little bit much, but it's all informative in our opinion. And there are CAM settings to turn off these preview stuff. If you don't like seeing the labels that tell you how much what the upper, lower, and upper level are, you can get rid of them. But I think most programmers, as you're programming, those little, we machine stuff to thousands and tenths of thousands. So every little value means something to us as machinists. So I think it's important for us to see as we're programming. Okay, so we updated both of those operations. Now I can see I can tackle these two little slots, and I didn't have to deal with there being 8 millimeters worth, having my little tool stick out an extra 8 millimeters to cut, to cut this little side groove. So we will now go to 2D Imachining again. We are going to do feature recognition by chains, because if we look at these undercuts, I don't have a floor that I can say, hey, I want to cut this floor. So we want to go switch to a different Mac position. I think it's position number 5. Yeah, position number 5. So I'm going to use curve and up to entity. So I'm going to pick here. I'm going to pick here. Now what I want to do is I want to machine this ledge here. So what I want to do is I don't want to machine the entire ledge. And what's nice about our feature recognition is I can just click on point to point, grab a point somewhere along this ledge that's, somewhere out there, further than where the stock is. I mean, I could have picked all the way in the middle here. It doesn't matter. It's just getting the tool past it. The feature recognition is going to automatically trim it up to where the exact edge of the stock is. So basically, we're giving hints. This is all about like giving subtle little hints to the feature recognition to say, hey, I would like you to machine this ledge, and I want you, I want you to cut this line out here, but it's going to be smart enough to trim that out. And we're going to do the same thing over here, up to entity. So I'm going to pick from here to here. Then I'm going to say point to point. I'm just going to pick a point, some arbitrary point along the line. This chain is cutting on the right side of the line. This, once again, we like to give good hints to the feature recognition. So making the chain so we're cutting on the left-hand side of the line, kind of the general for climb cutting, gives the feature recognition the, the hint of what side we want to cut. Because you can imagine if you just pick a straight line, how does it know what side of the line you want to cut? So we pick our 2 chains. We are going to go select our tool. I have a smaller version tool in here. I think it's a 6 millimeter. Yes, it is. We need to do our pocket depth because once again, it does the default depth is the depth of wherever you select your chain from. What's cool here is we can see where the updated stock is. So I picked the bottom of the chain. If you want to put a little negative delta depth to go a little bit past it, you can. That's the beauty of here. You can see it all. Click Save and Calculate, and we get our tool path. Let's go check this out in the new simulator. So let's zoom in on this a little bit. So I like to kind of zoom in here and look kind of at this angle here. And here you can see the tool is plunging out in air because this is the most important thing. We don't want tools plunging on material, right? And obviously everybody who's familiar with iMachining knows this. We do deep depth of cuts. Really plunging on the tool is really not good for the tool when you're cutting 2, 3, 4, 5 times the diameter deep. I can just step in single block and kind of see what the tool is doing. Can zoom it a little bit. We can slow down the simulation if we like. Kind of see what's going on. You can also turn the tool and the holder on and off. So a lot of the commands you're familiar with in the other simulations are also in this little menu over here. So they eventually, as we fill out the functionality, you'll have nice toolbars in here that turns all that stuff on and off. But we can increase the speed a little bit. What I like is really cool about using solid verification is you can see here that at the beginning of the cut we were engaged with so much of the tool, right? Maybe I think it was a 6 millimeter tool, so maybe I don't know, that looks like maybe 10 millimeters depth, and then by the end here you're getting to like I think it was 19 millimeters depth of cut. So I would expect out at the machine, because I see this in the simulation here, that the tool path is probably going to the cutting will sound different in the machine from the beginning of this pocket to by the time it reaches the end here, because you have more of the flutes engaged. So, being able to see these things in here is helpful before, you go out to the CNC and, you kind of wonder like, why, because obviously if you start cutting and in the middle of the pocket, it starts sounding different. You start getting, I don't know, a different chatter, maybe, this is a small tool, so obviously cutting that deep, it could, you could get some tool flex. So being able to see these things in the simulation here before going out to the machine is just super, super, super helpful. So we machine those 2 features, use our stock and target comparison. You can kind of see where we got material at. So really the only things we've finished up to this point have been this floor and the pocket wall of here. Everything else has been, roughed and not finished. And that's all been done on purpose because I didn't want to fill up the cam tree with more tools and more operations while we're programming. Okay, now I have just 2 more operations I want to show you, which is really quick. So what do we have? We now have in 2019, if anybody has looked at the other what's new stuff, we now have drag and drop. So we started with the drag and drop over here from the template manager. You can also drag and drop operations, and this is really helpful. So let's say we have this tool path here, the first one we did, which was roughing with our tool 1, and it was finishing the floor. Now, let's say I want to apply that same tool path to this face over here. I'm going to drag and drop that. Now, I will forewarn that sometimes in GoToMeeting, the recording of the same time while presenting messes with the mouse capture, but I tried it like 3 times before the presentation and the drag and drop worked just fine, but sometimes this does get a little funny. Let's see. Okay, so you hold down Control, you get the little cursor with the eye on it. I'm going to pick this face, let go. And now we get the tool path from this first operation automatically applied on that face. And what's nice now is we give you that preview that we do while you're editing the operation, the machinable feature preview that shows the full region of what you're cutting and the upper level and lower level. If you expand the operation that you just dragged and dropped, you can click on the geometry down here and we show that same preview. So you can get some of that information without actually having to edit the operation. It's also really good for just reviewing the program because you could go through each operation and click on that. So what's kind of cool here, you can see, even though the face that I picked, which we show the boundaries of the face with the yellow and the blue. So yellow is open edges and blue is walls. So you can see, even though this pocket or this face that we picked was something kind of complex, you can see that the machinable feature, excuse me, hold on, the machinable feature is actually pretty simple. right? I mean, it's really just a square rectangular, it's a pocket with just these couple edges. As you could imagine, in previous versions of SolidCAM, if you weren't using the machinable feature recognition, you would have to sketch this out. If you wanted to get this style cut, I would have to click on this face. I would have to start a SolidWorks sketch. You would have to come into the SolidWorks sketch. You'd have to, take these lines. You'd want to convert them up. You'd want to take the lines of the stock, convert them. You'd have to drag this out, and then I would be manually defining some sketch that said, well, hey, even though I'm, machining this feature here, I know that because of the way the stock is, I need to do all this sketching. I might have to, and now this, and let's be honest, even over here, we have a little bit of material. So, I mean, this is the type of stuff that, us as programmers, we have to do. And I mean, you won't, I'm not going to say that you will never have to do sketching again for pockets, because I think sketching is a tool we all have to use. And this is one of the benefits of being inside of SolidWorks is, we can sketch, we can do our geometry, we do our chain, and then I would have to do this sketch, right? So, okay, maybe this sketch only takes me, 2 minutes, 3 minutes to do. Obviously, the more complex the model gets, the more sketching you have to do. And then you got to go pick that. But with the feature recognition stuff, all I did was just pick this face, and then I let it do the machinable feature recognition. And you can kind of, I would say you could consider the feature recognition stuff automatic sketching. We do a combination of, we take the face, we extend it to the stock, we trim it all up, and then we also look for anything that would be undercuts, and we remove undercuts, which was, the shape over here. We also look to see if it's gouging the target anywhere. If it was gouging the target, we would also remove those areas. Once we find that region, then we're then finding the highest points of the updated stock and the lowest level and figuring that all out for you. And now the last operation I'm going to do is I'm going to do drag and drop, and you can do drag and drop to multiple operations. Once again, I hope this works through the GoToMeeting. Nope. Okay, we got my little icon. Nope, that time I think I was a little too quick. Get my icon, let me come off. 1, 2, 3, 4. So with multi-level drag and drop, and you can do the same thing inside of the iMachining operation, you can do multiple levels with multiple different heights and multiple depths all in one operation. And if I click on our machinable feature recognition, or click on the geometry and get a little preview, you can see that, let me just turn off the toolpath for a second, you can see all the machinable feature regions that were found automatically. So multiple levels, multiple pockets inside of one operation. The only limitation here is you don't want to pick pockets that self-intersect with other pockets. So if you wanted to do 3D roughing on this entire part, because you're just like, hey, I want to rough this entire thing, you're not going to use the 2D feature recognition stuff. What you want to use is 3D iMachining, rough out the entire thing, and then do the same exact steps I did here. But the difference being is we're just going to be picking finishing. So the only difference there is in each operation, you are just going to say, when you pick the tool, you're going to say, hey, I want this tool to finish the wall, or I want this tool to finish the floor. The updated stock is automatically carried over from the 3D iMachining stuff. So you can get super fast roughing with like a couple tools if that's the way you like to program. If you want to 3D rough the entire thing, you can 3D rough the entire thing, go to 2D iMachining and use the feature recognition stuff. And for all of you guys that are using SolidCAM and iMachining already, you will notice that you no longer, all the tools are still here for iRough, iRest, and iFinish, and you can still program that way if you like, but you don't have to do iRough, iRest, iFinish, and link your operations manually anymore. This is all done automatically in the new feature recognition. So in the past, you had to figure out which operation was connected to what, and that way it would know the rest material. Now it's all figured out automatically for you. You don't have to use those, but they are, they're still there if that's, if you need to use them. And last thing, maybe I'll just show here, is that we do have our relationship icons, relationship arrows. So this will show the relationship between all the operations. And as you can see in this part here, everything is using the updated stock. So everything affects everything else. So anything you do in this first operation can affect the toolpath for all of these other ones. So this new our new, I think this was new for 2018. This new operations relationship arrows is helpful, and it shows also what our parents and what our children's of that. And Sydney, I think that that concludes the presentation.
All I can say basically is in one word: wow. I've seen it several times already, but every single time I've seen it and played with it, I'm totally impressed. It's like getting to be a game. Now there are several questions here. Most of them have been answered, but we don't have enough time. But you can answer one question I see very quickly, and it is the fourth line down. If you see that.
Hold on, I'm trying to expand the.
I can read it out to you as well. Is it possible to include pre-drilling tool in multi-tool strategy?
Yes, absolutely. Yes, and that is important. So if you use pre-drilling, you are not defining pre-drilling in the multi-tool here. You would still create your drilling operation the way you like, and as you see in the 2D drilling stuff, the 2D drilling now is also using the updated stock for the levels and things like that. So if you wanted to pre-drill your several pockets with different levels and different things with one drilling, which I recommend, because if you do have closed pockets, the best thing you can do with closed pockets is to pre-drill the holes. Even if you're just drilling out the center of the hole, it really does help the end mill with helical entry. So you can still make a pre-drill operation in 2D drilling, do multiple levels, do the updated stock, and then in the linking page, you will still have use pre-drilling, and the same pre-drilling that you're used to in the previous version. If there's a little tip left over from the cone, it will plunge in the center, clean out the little tip, and then continue doing the pocket. So yes, pre-drilling is still supported and highly recommended, even with multi-tool.
Excellent. Okay, Anthony, thank you very much. You'll see any other questions, you'll see them in the report later on, so you'll be able to answer them separately. We're running kind of late now. I know, sorry. To mention that next week we'll be having the second part of our What's New in SolidCAM 2019 on 2.5D and some of the general options that we've added into the program. So I hope to see all of you again next week as well, same time, same place, and you'll all get an invitation to that. Again, Anthony, thank you very much for your time.
My pleasure to show everybody. Please use it, and I really hope, and I believe that we will really decrease your programming time with all the tools we did now. So, thank you.
All right, take care, everyone, and have a great weekend.
Bye, everyone.